Okay, so this is our first video on perpendicular lines at the grade 6 level. And probably this video is going to be 2 videos, otherwise it'll be a lot of content. But we'll get straight into it. Before we do get into it though, right, because we're looking at perpendicular lines, we're looking at lines here, really important that we know and we can recall, right, y equals to mx plus c. This is a fundamental equation of GCSE mathematics, and we know what this means. So hopefully, or we've got some understanding perhaps that m, right, what does that mean again? M is your gradient, which is how steep your line is, which really just means, right, if you've got a line like this, that's got a particular steepness. If you want to draw a line that's even steeper, okay, there you go. So gradient is just how steep your line is. And then similarly, right, or not similarly, but also we've got this C part over here, which is your y-intercept, okay, which is where your line crosses the y-axis. So if we go and draw in a coordinate axis, and that's your y-axis up here, it is literally where your line cuts through the y-axis, which is this point over here. Okay, and then also for gradient, right, there's an equation to find gradient. Maybe you're thinking rise over run. Correct, which is also the same thing as the change in the y-coordinates, right, that is the same thing as the rise of your line over the change in the x-coordinates, which is the same thing as the run of your line. So the rise, how kind of much up or down you're going, and the run is how far across you're going. So really important that if you need to, you make a note of that, and then we can begin with going into it. So before I get into perpendicular lines, and this might seem a bit strange, I just want to quickly recap how to find the equation of just a normal line. Because a perpendicular line, there's something important about the gradient that we're going to see in a second. But just to recap, I want to find the equation of this normal line here. So I want to get it into this form. Let's begin by finding my gradient m. So I know that my gradient m is equal to the change in y, or the rise of the change in x to run. And to do this, right, we need to choose 2 points on our line that exactly go through the corner of a square. So that's a good point to go for, and that is a good point to go for. Note, you could choose any points on this line. You could go for down here if you wanted to, and here. Oh, the line's been a bit, or here. That's fine, but it must go exactly through the corner of the square. I'm just going to go for my 2 original ones, which are here and here. Okay, and let's go and draw in my triangle. So we're going across by 1 in the positive direction, and I'm going up by 1 square, 2 squares in the positive direction. So across by 1, up by 2. So the gradient, the change in y, or the rise, is going to be 2 over the change in x, or the run, which is going to be equal to 1. So 2 divided by 1 is equal to 2. So the gradient of this line here is equal to 2. Right, the C part, the y-intercept, C, is just where your line crosses the y-axis, which is this one here, which is at the point down there, which is -2. I think my line's been a bit jolted. It should be exactly going through -2. So C is equal to -2. Therefore, the equation of this line is going to be y is equal to m, or m is 2. And that's really important, right, as we're going to see in a second. So 2x plus our C value, which is equal to -2. So the gradient of this line here, and let's highlight it because we're going to see something important in a second. The gradient here of my line is 2. Right, let's go and draw now a perpendicular line to this red line. Right, and perpendicular, maybe you're thinking, I know what that means from different topics like loci. Perpendicular means at right angles. So there we go. I've gone and drawn in a blue line, which is exactly, right, at 90 degrees. So exactly perpendicular to that red line. They meet at 90 degrees. Let's now go and find the equation of this blue line here in the same kind of way I did for the red line, and we're going to see something really important about the gradient. So let's go and choose 2 points that exactly cut through the corner of the squares. So that's a good point, and that's a good point to go for. I could have gone for any 2 points. It makes no difference. You'll get the same answer. And I could go and draw my triangle, and also note my triangle could go this way and then down, and it could also go this way and then across. It makes no difference. Okay, we're just got to be consistent with what we do. And what I mean by that is, right, is that we know if we're going up or down, right, up is in the positive direction, down is negative, and then across, right, across to the right is plus, to the left is negative. A bit like the way, you know, if you're going across to the right, we're getting more positive. If you're going up, positive. Anyway, I'm going to choose to go down first and then across like this. I've got to go and follow the path that I've chosen. So I've gone down and then across. So I've gone down, I'm going down in the negative direction by 1. So down by 1 and across by 1, 2, which is in the positive direction. So that's across by +2. Therefore, the gradient in my blue line, m, is going to be equal to, well, the change in the y-coordinates, or the rise, is -1. So -1 over, we're changing the x-coordinates, which is positive 2. So 2 across. So I've got minus 1 over 2, which I can write like this, minus 1 over 2. Okay, and look, the y-intercept here is a little bit irrelevant, so I'm actually just going to stop there for the time being and just highlight, right, that the gradient of my blue line is equal to negative 1 over 2, which actually, there's something really important we can draw from this, which is this here. To find the perpendicular gradient, you take the negative reciprocal of the other gradient, which just means, right, to find the gradient perpendicular to this 2 here, because 2 can be written as 2 over 1, right, you flip it. So reciprocal basically just means you flip it to give us 1 over 2, and you make it negative. So 2 we can write as 2 over 1, they mean the same thing. Reciprocal, you flip it around to give us 1 over 2, and you make it negative. And that is the case for any that's the case for any perpendicular gradient. And we'll look at a few examples now. Okay, so what we'll do is we'll go through 2 sides like we did in class of examples. In class, you got these stuck into your books, but I'll go through it on the screen, and then that will cover us for this video, and then you can try question yourself at the end. But we're just going to build right through the fundamentals with this. So yeah, let's begin. And you can make a note of this if you wish to. So question 1 is write down the negative reciprocal of the numbers below. It's just testing our understanding, right? Do we know what negative reciprocal means? Because that's the key thing in finding a perpendicular gradient. So 2 is the same thing as 2 over 1, because 2 divided by 1 is just 2. So I can write it as 2 over 1. And negative reciprocal, right, I flip this number over. So I put the 1 on the top, the 2 on the bottom. So I put 1 over 2. And I make it negative. So I make it negative 1 over 2. Okay, and that is my first answer, negative 1 over 2. Done. The second one, right, to take the negative reciprocal of 2/3, again, you flip it over. So I put the 3 on the top and the 2 on the bottom. And negative, I've got to go and make it negative. So minus 2 over 3. And that is my answer with that one there. So maybe now you could try the 2 below. Hopefully you're getting the idea a little bit now. So C, to take the negative reciprocal of this one here, I've got to flip over my numbers. So I put the 2 on the top and the 1 on the bottom. And it's already negative. So if I put like another negative next to that negative, right, it's going to make it a positive gradient. So 2 over 1, and it's positive, which is the same thing as just 2. So that is my answer on question C. And then this one here, negative 4. Well, again, negative 4 I can write as negative 4 over 1. It means the same thing as minus 4. Okay. And then negative reciprocal, I've got to flip it over, so write it as 1 over 4, and make, it's negative 1 over 4, negative reciprocal, so make it negative, we'll make it a positive answer. So there we go, 1 over 4. That is my gradient, or my negative reciprocal. Okay, good. So these are like knowing this is just like a key skill in being able to work out perpendicular gradients. So let's get on to some more questions up here. Right, 2 says, write down the equation of a line that is perpendicular to the following. So let's write down the equation of any line perpendicular to y is equal to 3x plus 4. What I want you to see here is, right, that the gradient of this line is that value there. So the gradient here, m, is equal to 3, which I can write as 3 over 1, because 3 divided by 1 is the same thing as 3. It just makes it clearer to see, right, when I get my perpendicular line, so my line at a right angle, that is where I take the negative reciprocal, like I've done over here. So I take this gradient, I flip it, and I make it 1 over 3, okay, and I make it negative. So the perpendicular gradient to this line here must be minus 1 over 3, okay, and we know, right, the equation of a line is in the form y is equal to mx plus c. I've got the gradient, which is minus 1 over 3. The value of c could be anything, right? If I just roughly draw this out as a sketch, okay, let's go and do that really quickly. So this line here, y equals 3x plus 4, will look something roughly like this here. That is y is equal to 3x plus 4. Okay, a line perpendicular to that, it could be any line, right, that is just at right angles to that line. So it could be this one here, or it could be this one here, or it could be this one over here. All of these lines are perpendicular, but clearly they cross through at a different y value on the y-axis, but that value doesn't matter. It can be anything. As long as your gradients are the same, which is minus 1 over 3 in this case, the value of c can change. It doesn't matter. So let's go and choose the value of c. Okay, so I'm going to go and say that for my perpendicular line, y is going to be equal to, the gradient must be minus 1 over 3. So all of these blue lines here have a gradient of minus 1 over 3. So minus 1 over 3. And it's always x in our equation. And the value of c, it can be anything. I'm going to go for plus 4, because why not? Okay, but again, this value here, it could be anything, any value. Hopefully that kind of made a bit of sense there. Right, as long as the gradient is perpendicular, that can be anything. That is absolutely fine. So that there is the answer I've gone for. But as long as the gradient bit is minus a third x, or minus a third, that is what you need there. B, a bit trickier, because I want you to write, you've got to be a little bit careful here. It's saying the equation of a line perpendicular to 2x plus 3y equals to 3. That is still an equation of a line, but it's not in the form y equals to mx plus c. I've got to make sure it is in that form. So I've got to do a little bit of rearranging first. I've got to go in, because I want y to be the subject on its own, I want to get rid of that 2x. I can do that by taking away 2x from both sides. So take away 2x and take away 2x from both sides, which then means, right, that these are going to cancel, which is good. And I can say, well, I've got 3y left over is equal to 3 minus 2x. I'm going to write it as minus 2x plus 3, minus 2x plus 3, because that is now closer. You know, I've got the x part first, which is useful. I could have written it as 3 minus 2x, but this is a little bit nicer. I've then got 3y. To get y on its own, I've got to go and divide through both sides by 3 and divide everything there by 3. Okay, which then means that these 3's here are going to cancel, and I get y is equal to, and the way I can write this, right, that's the same thing as minus 2x over 3, minus 2x over 3, plus 3 over 3, plus 3 over 3. I've just separated out the terms over 3. That is exactly the same thing. So I've got y is equal to, well, the first part, minus 2x over 3 is just that, so minus 2x over 3. The minus, it could be up here, it could be down here, but it just looks, it's conventional to write it in the middle like that. I've got plus 3 over 3, which is the same thing as just plus 1. 3 divided by 3 is equal to 1. So now, that was quite a tricky one really, because I've got to rearrange it first. I've got it in the form y is equal to m, where my m value here, m is equal to minus 2/3. So this part here is my gradient. Okay, so minus 2 over 3. Okay, right, but I want the equation of a line that is perpendicular to this gradient here. So I can go and say that, well, the perpendicular gradient, I've got to go and take the negative reciprocal. I've got to go and flip this and make it 3 over 2. And because it's already negative, if I make it, you know, take the negative reciprocal of it, so take the negative of the negative, it will just become a positive. So 3 over 2. Therefore, right, the equation of my line is going to be y is equal to, it's got to have that gradient, so 3 over 2x, and the y ends up the value of c, similar to the first one, it can take any value, it doesn't matter, as long as the gradient is 3 over 2, the c value can be anything. Let's just go for plus 4 again, right, but again, this here, that can take any value, okay? So if you need to, you can always rewind and go through any of that again. You need to. I would say that one there particularly was a bit more of a tricky question, but it's good to have that in there because that is the reality of what they might ask you. Okay, side 2. So a couple more questions and then you can try a your turn at the end. Okay, we've got write down the equation of a line that is perpendicular to 3x plus 2 and passing through the point, the coordinate 0, 4. Well, again, what is the gradient of this line here? Again, equation of a line, y is equal to mx plus c. The gradient of this line here, m is equal to, it's that 3 value, so 3. So the perpendicular gradient, that's the same thing as 3 over 1, is going to be equal to the negative reciprocal. So I flip this over, I make it 1 over 3, and I make it negative. Okay, but this time I can't go and choose the value of c, because I'm told, right, I want my line to be perpendicular to this line here and passing through the point 0, 4. Just to show you what this really means, let's draw this out in a bit of context. Right, so if I go and draw out a coordinate axis like this, like this. Y equals to 3x plus 2 will look something like that, where this point here is 2. Okay, and that's y equals to 3x plus 2. The question is saying I want a line perpendicular to this line here, which I've just drawn there, and it's got to pass through the point 0, 4. So if I can draw it in blue, right, 0, 4 is going to be sort of somewhere, let's go make this a little bit bigger, sorry. It's going to be kind of somewhere up here. 0, 4, 0 across and 4 up is going to be somewhere there. So it's got to go through this point here and perpendicular, so it's got to go through that point there, okay, which is the point 0, 4, so the y point is 4, and perpendicular to the red line, like that. Okay? So it's just saying, right, the value of c must then just be 4. And because, right, it's 0 and then 4, you can maybe spot that it's just going to be that value there, which is 4 for the y-intercept. So the equation, right, of my perpendicular line, right, is going to be y is equal to, the gradient is minus 1 over 3, negative reciprocal, so minus 1 over 3, x, and then the value of c is going to be 4. It goes through the y-axis at the point positive 4, so plus 4. Okay, and that is my answer with that one there. Okay. The next question, just by glancing at it, is trickier because this time, right, the coordinate, if you notice, is not 0 at the front, you've got 4, 1. So I've got write down the equation of a line that is perpendicular to y equals minus 2x plus 1, and it passes through 4, 1. But start in the same way as before. The gradient, okay, of this line here is minus 2. So the gradient here, m, is equal to negative 2. Therefore, the perpendicular gradient, I should really say m there and m over there, but that's fine. Right, that's the same thing again as minus 2 over 1. I'm writing it over 1. It's just easier to kind of flip it over. Right, so again, negative reciprocal, perpendicular gradient is going to be 1 over 2. And I make my gradient negative, negative reciprocal. 2 negatives will just give me a positive. So that is the gradient of my negative of my perpendicular line, okay? And it goes through the point 4, 1. So this time, okay, well, again, I can't just go and make up a value of c. I've been told it goes through that point there, 4, 1. And notice, right, this 4 is an x coordinate, and that 1 is a y coordinate. So my line is going to be something like y is equal to, and let's go and write it in blue, because we're looking at the perpendicular line. So we're looking at y is going to be equal to my m value, my perpendicular gradient is going to be 1 over 2. I've then got this x here. Let's write it a bit smaller, sorry. So I've got y is equal to 1 over 2 x plus some c value, which I yet do not know. Right, but I know I've been given an x value of 4 and a y value of 1, which I can substitute into this equation here. So if y is going to be equal to 1, I can say 1 is equal to 1 over 2. My x value is equal to 4. So 4, and then plus c is what I'm trying to find. So I've now got an equation here with one unknown that I can rearrange to find. So 1 is equal to half times 4, half of 4 is 2, plus c, take away 2 on both sides, take away 2, take away 2, they cancel. 1 minus 2 is equal to minus 1. So c is equal to minus 1. Okay, so I've got my value of c now, which is really useful. So the equation of my line is going to be y is equal to my perpendicular gradient, which is 1 over 2 x, and my value of c is equal to negative 1. Okay, if you wanted a bit more context, you know, to see visually what's going on there, right, just really quickly, that is my answer. So if you get that, that's fantastic. But just to make sure you kind of really understand what is going on there, let's draw out what was going on behind the scenes. So the original line, right, if I just draw a quick sketch, was something like that. Y equals minus 2x plus 1, negative gradient going through the point 1, something, right, like that, where that point in there is equal to 1. And that is y is equal to minus 2x plus 1 plus 1. I wanted the equation of a line that is perpendicular to this line here that goes through the point 4, 1. So somewhere 4, 1 over here, okay, which if that point there was 4, 1, I substitute in, again, that x value of 4, the y value of 1, into this equation, okay, and I found that my c value was equal to minus 1. So this point down here was equal to minus 1. Okay, so what you can do now is you can try that your turn, and I'll go through it on the next slide, and that's going to be it for this video. Okay, so 20 minutes in, but hopefully this is okay. Okay, pen. So write down the equation of the line that's perpendicular to y equals to minus a fifth x plus 2, and it passes through the point 1, 7. Okay, so this is one of the trickier ones again. Right, let's work out the gradient of this initial line. Well, the gradient is just minus a fifth. So m here is equal to minus 1 over 5. The perpendicular gradient to that is going to be, I flip this over, so 5 over 1, and it's already negative. Negative reciprocal is going to make it positive. Okay, and again, this one here, that is my x coordinate, and that 7 is my y coordinate. So when I go and put it in eventually to y equals to mx plus c, I can use the fact that my gradient is 5 over 1, which is the same thing as just 5, and my x value is 1, my y value is 7 to find c. Let's go and do that. So let's use blue for my perpendicular line. My new equation of the perpendicular line is going to be y is equal to m, my perpendicular gradient, which is 5. I've got this x part here, x, and I don't know the value of c, so I've got to go and write in plus c, which is there. Well, I know that y is equal to 7 and x is equal to 1. Let's go and substitute those values into the equation. So y is 7, that's equal to 5 times my x value, which is equal to 1 plus c. So 7 is equal to 5 by 1, which is 5 plus c. 5 over what is 7? 2. So c is equal to 2. So my line's going to be in the form y is equal to perpendicular, my gradient m is equal to 5, so 5x, and my c value is equal to 2, so plus 2. And that there is my answer. Okay, y is equal to 5x plus 2. Again, right, if you want to really understand what is going on there, let's go and draw out what is going on here to show you what is happening. Okay, for a bit more understanding. So here's my coordinate axes. Right, this line, y equals minus a fifth x plus 2, will look something like this. It's got quite a low sloping gradient, so that's going to be the value of 2, and that's y equals minus 1 over 5x plus 2. I wanted the perpendicular, let's go and draw it in blue, line to pass through the point 1, 7. So 1, 7 will be somewhere up here. Okay. And it just so happens, right, that both have a y-intercept of 2. They both cross through the y-axis at 2. So that's quite nice, right? So they both go through at 2. Okay, and that's the point there, which is 1, 7, and they're perpendicular. Okay, it's just a coincidence that they both go through the y-axis at 2, but that is really what is going on with this question. Okay, quite a long video. Hopefully that was useful. I really went into the detail there about what perpendicular lines are, because often we learn stuff and it's like, well, what is really happening? I don't really quite get why are we flipping everything over. But hopefully it all made sense at the start. And as always, the power of YouTube, you can rewind and go through whatever you need to at any point. Okay, thank you.